Okay, my name's Kevin Siebert.
Mitch Supplewitz. Sean Roberts.
My name is Brian Sparks, and our group's presentation is about biomass gasification. This is the same type of technology that was announced in Back to the Future movies, with the DeLorean being able to be ran off of garbage, essentially. First, a brief history. Gasification is basically just deriving energy from organic matter. This is actually a fairly old technology. First experiments were done by scientists back in the 1700s. It was initially used for transforming coal into what's called town gas. It actually became popular during World War II in Germany. The government in Germany actually worked to convert several automobiles to run off of gasification power, and they implemented that during the war and transported their technologies elsewhere. And then in the 1973 energy crisis, there was the realization that we need to be looking away from oil and towards a more sustainable type of energy, and that's whenever the biomass aspect of gasification came about. And this is using biomass material, wood chips, grasses, corn stalks, different things like that to produce energy. And in present time, what they're working to do now is to use gasification processes to derive electricity, oils, ethanol, methanol, different type of fuels like that, which we'll cover later on too. And basically, gasification is a chemical process. It's not a biological process. There's nothing like decomposing. It's all due to chemical reactions inside the gasifier. And basically what we have is our carbon input, C, and we infuse air, oxygen, different items like that, and they combine in different ways within the gasifier to produce our producer gases, as they're called, or synthetic gases, carbon dioxide, nitrogen, carbon monoxide, and hydrogen. This is kind of a brief table of the type of elemental analysis of different type of biomasses that they use. For example, corn cobs, straws, different things like that. And you can see the conversion of carbon to energy for each item. So you can see some of them are more energy efficient than others to use. And with any type of chemical reaction, you're bound to get contaminants. Some of these are ammonia, methane, hydrogen sulfate, all that. And the main one you get is what they call tars. And the tars that are referred to really mean different things to different people. You get different ones out of different processes and all that. So what you have to do with these is you have to work to eliminate these contaminants. And one way to do that is to introduce a catalyst reforming unit into your system, as seen here. So basically, you have your gasifier produces your gas, and then it goes to a catalyst, and that works to break down those contaminants into other useful products. And here's an example of how this works. They use the example of a tar, the C7H8. They infuse hydrogen into this catalyst unit, and it breaks down into methane, which they can capture and reuse in other forms.
Okay, you can get diverse types of energy that's converted from biomass fuels or charcoal, producer gas, electricity. And charcoal, we all know what charcoal is. Producer gas is also referred as wood gas, and you can use it to power cars. And it can reduce the demand for foreign oil. And producing electricity is really what, people are striving for, and these are the these are the ag ranking cycles, the different ways to produce electricity. And pyrolysis is chemical transformation of organic material brought about by heat and absence of oxygen. He showed you the process. And combustible gas, and you make oil, and then it's easily storable, and you can transport it easily. And also you can get rid of your industrial waste, which can be an issue. Okay, utilization of combustible renewables worldwide, and biomass is 62% of the energy source of renewables. And the use of biomass by region, see, Africa has 60% of their energy comes from biomass, in South Asia and East Asia. And you notice that down there in North America and Middle East and Europe, we use very small percentage because I guess we just have access to oil. And what OECD is it's a worldwide organization that's used for economic and social issues and stuff. And they're more developed countries. And you notice your final consumption of OECD total is a lot less than non-OECD total. So the less industrialized the nation is the more likely they are to use biomass. And India has, India's population is 70% rural. Oh, am I 2 minutes up?
Yes.
Okay, well, anyhow, they have a program. And okay, there's
All right, we got gasification implementation. Make this quick. We all know natural resources are depleting right now, and change is needed. We need to go green. All right, cogeneration. Cogeneration is combining 2 different forms of electricity. Could be 3 different forms in a one plant. It's very effective, and it's just starting to get real popular now. EIU, they're doing a new power plant now. So they're implementing a biogasifer, which it'll reduce greenhouse gas emissions, carbon dioxide emissions. Let's see here. The plant is the first of its kind in this region. It's also one of the largest of renewable power plants to be implemented. They'll be using the wood chips from local logging industries and paper mill waste to produce the power in the plant. The products will be burned in a airtight container to provide oxygen, and which will produce the synthetic gas, which is used. The gas is used to heat the boilers, which produce steam to heat the university and also create power by generating turbines. And they also have benefits, but there's also some benefits that aren't important, or that are important, but many countries can't afford to implement it. It's the wrong kind of cash. Just threw it on there. But countries need to realize that this is important, and it can save a lot of money. This startup fee is what gets a lot of people. We were lucky enough to be sponsored by Honeywell and the EIU plant to implement ours. And there's a little diagram here to show how effective it is. And then they also have some automobiles that are running, but they're still in the developmental stages right now. And then here we go, Sean.
All right, so basically I gotta explain what's going on. Right here is where your biomass goes. It's your wood chips, your walnut shells, whatever you have. It goes into your hopper. What ends up happening is you actually have a combustion chamber here where it starts, you feed in a little bit of oxygen to start it to burn, and it's sealed off. So what ends up happening is it starts to slow cook your biomass right here to where it starts producing those fumes. This one here is a downdraft model. So what ends up happening is there's a negative draw, so it ends up pulling your gases down and out, and this ends up going on to other parts of your gasification machine. what they also have in here is this is also another downdraft. Your materials up here. This is where the gasification process takes place. It's actually through the Venturi effect. It's actually the gas is siphoned out. It's sent through some heat exchangers to cool the gas down. It's sent through some filters to take particles out of the filters, and then it can be run on up into an engine. So that's basically the gist of how a gasifier works. There's also some other forms. There's a campfire gasifier, which is an updraft. Basically, the way it works is instead of the air coming down and going through, it comes up, and it will actually siphon off, and you'll get some burning, but then you'll also have gas burning up above what would look like your it basically creates two separate flames. One's your wood gas burning, and then the other one is your everything else, or is your biomass burning or cooking. So it's a really interesting technology.
Any questions? Gasification.
Is there a concern that this technology would outpace the resource that feeds it?
As of right now, I don't think there's that much of a concern. That is one of the things that I think needs to be looked into later. Granted, a lot of the byproducts, you get a biochar, so if, for instance, a farmer wanted to use this idea, he would actually be able to take his corn stover, his corn stalks that were left over, use it in this process, and it creates a biochar, and he can just spread that biochar back onto his fields in order to reproduce or to refertilize and not take as much nutrients from his ground as if he were to just let the corn stover lay on the field after he was done harvesting. So there's definitely options, because this can also be used in sewage. There's some other things where you can take old tires and grind them up, and it goes along the same process. There's a couple tweaks on it where you basically pressure cook fine rubber dust, and you'll actually get oil and a combustible gas. So
I was just curious because the turn of the 20th century, wood was the primary heat source. It then went to coal because wood started to become scarce.
yeah.
And now we're going back to a byproduct of wood.
Yeah. Well, and the thing about this is it doesn't have to just be wood. Like when we use the DeLorean, I don't know if anyone's seen the Back to the Future. He just kind of started tossing banana peels.
Yeah.
Basically, this process can use any substance that's made of carbon. So, I mean, if it was living at one point, it can be broken down and made gaseous. I mean, you can basically
To the landfills.
Yeah, you can use the landfills, and I mean, you can just break anything. You can break it down to get what you need.
Thank you. Other questions? Questions? No? Yes? Okay. Photo for the group.